Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be using models to explain the Pythagorean Theorem and discover why a squared plus b squared is equal to c squared. Before we do, let's kind of look at a little bit of review of models and finding area. So in example 1, it says find the area for each of the following, leave in terms of a variable if needed. So in this set of problems, we have squares and rectangles. So just by way of review, the area of a square is just side squared. So you just take one of the sides and square it. The area of a rectangle, hopefully you remember, is length times width. So in problem A, we have a square because we know that all four sides of this square are 4 centimeters. So to find the area of this, we'll just take our side and square it. So 4 squared is 16. So the area here would be 16 square centimeters. In problem B, we have a rectangle. And so the area of a rectangle is found by multiplying the length times the width. So 2 times 5 would give us 10 square inches. All right, in problem C, we have a square, and they didn't give us a numerical value for the side length. All they gave us was a variable. So really, all we know in this problem is area, or capital A, is equal to lowercase a squared. In this problem, since they didn't give us a value of a, there's not really anything else we can do here. So this is our final answer for problem C. All right, in problem D, they've given us a rectangle, and our dimensions are a and b. So our area will simply be a times b, or you can write it like this, ab. Excuse me. Example 2, for each of the following products, draw a rectangle or a square and label it with the side lengths indicated by the product. So in problem A, we have the product 7 times 5. Now, I want you to think, would the model of 7 times 5 be a rectangle or a square? Pause the video and think about it. All right, welcome back. Hopefully you said that the model would have to look like a rectangle because our sides have different lengths. So the short side would be 5, the longer side would be 7. All right. In problem B, our product is 6 squared, which is the same thing as 6 times 6. So this would have to be a square. I'm just going to put these little marks here to indicate that all of these sides are the same. And if I label the sides, I'd just put a 6. All right. In problem C, we have x times y. This would have to be a rectangle because we have different lengths. One of the lengths is x and one of the lengths is y. It actually doesn't matter which label you put where. Okay. All right, try problem D on your own. All right, let's see how you did. Hopefully you drew a square where all of the side lengths have a length of c. All right, in example 3, a right triangle is shown below with side lengths a, b, and c. Squares have been drawn off each side of the rectangle. Now here's what that means. So in our right triangle, we have one of our legs is labeled with a, and there's a square drawn off of that side that has all the sides have a length of a. Okay. Then we have another side, our other leg, B. It also has a square drawn off the side of it where all of the side lengths of that triangle, or excuse me, of that square are the length of B. And then finally, for our hypotenuse, which we've labeled with a C, if a square is drawn off the hypotenuse, all of the sides of that square would all have to have a length of C. All right. So in problem A, it says write the areas of the squares inside of them. Express the areas in terms of the variables A, B, and C. So let's start with the square for side A. The area of this square would have to be A squared, because we don't have a value for the length of side A. All we can do is write it in terms of A. Likewise, on side length B, the area of that square would just have to be B squared. And for our big square, the area of that square would have to be C squared. So in problem B, it says, how do these areas relate to the Pythagorean theorem? So remember, in the Pythagorean theorem, we know that our legs, the sum of the legs squared is equal to the hypotenuse squared. So we know that A squared plus B squared must equal C squared. In problem C, it says if the area of the smallest square is 32 square inches. So let me label that. So what they're saying is, what if this is 32 and the area of the medium square is 48? What would we know about the area of the largest square? Well, according to the Pythagorean theorem, we would simply add the area of each square. So 32 plus 48 would equal the area of the largest square. 32 plus 48 has to equal the area of the largest square. So if I add those together, let's see, that would be 80 equals C squared. So now I know the area of this square is 80 square inches. All right. In problem D, it says find the length of each side of this right triangle. So let's start with side A. Side A, to get side A, we would take the square root of 48, and it says to round to the nearest tenth. So I'm going to put, we'll be rounding here, square root, 48, and that's approximately 6.9 units. So I'll label side A with 6.9. Okay. Now let's get the side length for square B. So we know the area of the B square is 32. So if I took the square root of 32, that would be approximately 5.7. So I'll label that with 5.7. Now to get my hypotenuse, I want to find the side length if the area is 80. So square root 80 would be approximately 8.9 units. So this side is approximately 8.9 units. All right, example 4. Here we have a model that shows a right triangle. So let me draw that in. Here's our right triangle. And it has squares drawn off each side of that right triangle. So what information they've given us is the area of square 2 is 36 units. So I'm going to try to squeeze that in here, 36 square units. The area of square 3 is 64 units. Find the area of square 1 and find the length of each side of the rectangle. So here's what I know. The area of the small plus area of medium will always equal area of the large if the triangle is the right triangle. The area of the small plus the area of the medium will always equal the area of the large square if the original triangle is a right triangle. So I'm simply going to add 36 plus 64, and that gives me 100. So now I know the area of this square is 100 square units. So I found my first answer. Now the second thing they want you to do is find the length of each side. So side number 1, if the area is 100, to find the side length, we would simply take the square root of 100. So square root 100, and that would give us 10. So I know our hypotenuse is 10 units long. Now the area of square 2 is 36. So to find the side length, we would take the square root of 36, which is 6 units. So this leg is 6 units. And the area of square 3 is 64. So to get the side length, you take the square root of 64, which gives me 8 units. So our legs are 6 units and 8 units, and our hypotenuse is 10 units. All right, example 5. If the area of square 1 is 25 units, and the area of square 2 is 9 units, what is the area of square 3? Now, I want you to stop and think about something. In example 4, we added the 2 squares together to get the third. Should I add the 2 squares in this problem, the 25 and the 9, to get the area of square 3? Think about that for a minute. All right, hopefully you said no, because if I add them, I would get, don't write this down because it's incorrect, I would get an area of 34. But in this problem, our largest square is here. So this one has to be the largest area. So there's no way that square can have that medium square can have an area of 34. So let me erase that 34 there. Okay. So instead, what we should do is take the 25 and subtract the 9, which gives us an area of 16. Now, if you add the small plus the medium, then you would get the area of the large, because 9 plus 16 is 25. Okay. All right, example 6. If the area of square 1 is 400 units, let me put a 400, that's our largest square. The area of square 2 is 144 square units. What is the perimeter of square 3? Now, we cannot answer that question yet because we need to find the area first. So I'm going to write this down. Find area. Find the area of square 3. So to do that, we would have to take 400 and subtract 144. So 400 minus 144. And that would give me the area of square 3 is 256. All right. Now, we still can't find the perimeter because we don't know the length of each side. So step 2, find the side length. Find the side length. Let me pause for a minute while you get that written down. Okay. So to find the side length, you take the square root of the area, and that gives us 16. So I know now each side of this square is 16 units. Each side of that square is 16 units. And finally, step 3, we can answer the question, what is the perimeter of square 3? So find perimeter. Now, to find the perimeter of any shape, we can simply add up all 4 sides, or we can just multiply by 4. So 4 times 16, and that would be 64 units. So there's our perimeter. So that problem took a few extra steps to solve compared to our other problems. All right, example 7. The vertices of the squares below can be joined to form a model of the Pythagorean theorem. What is the area of the largest square? And then what is the length of each side of the largest square? Now, notice in our smallest square, all they gave me was a perimeter. All they gave me was a perimeter. So I need to find the length of each side. So step 1, find side lengths. So 28 divided by 4 is equal to 7. So I'll put a 7 there. And 96 divided by 4, I think is 24, but I just want to check. 96 divided by 4. Yes, 24. So these side lengths are 24. Okay. Now that you've got the side lengths, now we want the area of the small and the medium. So let me write that down. Find area. You're going to want to refer to this page of notes when you're doing your practice assignment. So now we're going to find the area of each square. So 7 squared would be 49. So I know the area here is 49 units. And then 24 squared, type that in, 24 squared is 576. I'll put that there. Now, they told me in the original problem that these 3 squares can be joined to form a model of a Pythagorean theorem. That means that we can add these 2 areas together. So I can take my 49 plus 576, 49 plus 576 to get an area of 625. So the area of the big square has to be 625 square units. Now, the last thing they asked us to do is find the length of each side of the largest square. So to do that, we'll take the square root of 625 and we get 25 units. So this is 25. So these 3 sides can be joined together to form a right triangle where the smallest side is 7, the other leg would be 24, and the hypotenuse would be 25. All right, example 8. If the squares shown below are joined at their vertices, would they form a right triangle? So the first thing we need to do is find the area of each square. So we know the area of the medium square is 144. What about the area of the small square? Well, 9 squared would be 81. Now let's get the area of our large square, 21 squared. So this would be 441. Now, if they form a right triangle, the area of the small square, 81, plus the area of the medium square, 144, would equal the area of the largest square, 441. Whoops, sorry. It should be 441. 441. Now, let's see if that statement is true. So what is 81 plus 144? And that is 225. So does 225 equal 441? No, they're not equal. So no, these squares would not form a right triangle because a squared plus b squared does not equal c squared. And that concludes today's lesson using models to explain the Pythagorean theorem.